Students, now we are going to discuss the next topic, that is thermodynamic equilibrium. So it is asked in the question manner, define thermodynamic equilibrium, write their types. So thermodynamic equilibrium is related with the definition. First of all, we are going to focus. A system is said to be in thermodynamic equilibrium if there is no change in any thermodynamic functions or state functions, then it is called as thermodynamic equilibrium. Means the systems is having fixed condition of state function. It is not going to change, it remain as it is, then it is called as the state function. So there are three types of thermodynamic equilibrium. Number one, thermal equilibrium, chemical equilibrium, and mechanical equilibrium. So definition says that a system is said to be in thermodynamic equilibrium if there is no change in any thermodynamic functions or state functions. इसका मतलब क्या है? जो सिस्टम है उसका कौन सा भी थर्मोडायनामिक फंक्शन और स्टेट फंक्शन कभी चेंज नहीं हो सकता, उसे कहते हैं सिस्टम इन थर्मोडायनामिक इक्विलिब्रियम. मीन्स देयर इज अ फिक्स कंडीशन and no change in that state functions as well as thermodynamics function, then it is called as system in thermodynamic equilibrium. Now the types of it is not given in our syllabus, only types are given, but it's simple explanation I am giving. Thermal equilibrium means system is said to be in thermal equilibrium if there is no change in the temperature, that it is said to be thermal equilibrium. Second is chemical equilibrium, means system is said to be in chemical equilibrium if there is no change in any chemical composition, then system is called as chemical equilibrium. And finally is mechanical equilibrium, when there is a no work is done, no mechanical work is done, then system is said to be in mechanical equilibrium. So in this way, these are the three types we have discussed: thermal equilibrium, chemical equilibrium, and mechanical equilibrium. So that is the considered part and the types when you are considering the thermal equilibrium, the chemical equilibrium, and mechanical equilibrium. So thermodynamic equilibrium means there is no change in any kind of state functions as well as thermodynamic function. So that is about the thermodynamic equilibrium. Here this criteria is applied by means of three way. Their types are provided only in our syllabus. Their explanation is not given. That's why we are interested only in their types. So that is about thermodynamic equilibrium. So this way you considered the thermodynamic equilibrium. After that, their types we have taken: thermal equilibrium, chemical equilibrium, and mechanical equilibrium. After that, next portion we are going to discuss what is thermodynamic process and what are different types of process. So I am talking about the process. Process is different and system is different. So first of all, we are going to discuss the definition of process. A transition from one equilibrium state to another equilibrium state is called as process. It is a thermodynamic process. So what do you mean by system? System means it is a part of universe which is under thermodynamic investigation, that we are calling as a system. But process means a transition from one equilibrium state to another equilibrium state, that is called as the process. Means one state changes to another state. Transition means change. It changes from one state to another state. Then it is called as the process. Clear? Means a transition from one equilibrium state to another equilibrium state is called as the thermodynamic process. Actually, there are six types of thermodynamic process. First is isothermal process, second is isobaric process, third is isochoric process, fourth is adiabatic process, fifth is reversible process, and number six is irreversible process. So these are the six types we are going to discuss in detail in our syllabus. So these processes are given according to their types. We are going to discuss detail about this. Isothermal process means the process in which temperature remain constant, that is called as isothermal process. Iso means same, therma means temperature. Isobaric process means the process in which pressure remain constant. It's called as isobaric process. Delta P is equal to 0. After that, isochoric process means it is the process in which the volume remain constant. That is called as isochoric process, means delta V is equal to 0. Adiabatic process means the process in which there is no exchange of energy. That is called as adiabatic process, thermally insulated process. Reversible process means the process in which driving force is infinitesimally greater than opposing opposing force is called as the reversible process. An irreversible process means the process in which driving force is much more greater than opposing force. Such a process is called as irreversible process. So these are the six types of the process we are going to discuss. So this is the considered part. Now we are focusing on the first type, that is write note on isothermal process or write the characteristics of isothermal process. So first of all, we are going to discuss their definition. It is defined as the process in which the temperature of the system remain constant throughout the change of state of the system. Means it is the process in which temperature remain constant, it is not going to change. As temperature remain constant, you can write delta T is equal to 0 and delta U is equal to 0 and Q is not equal to 0. Suppose we are considering the boiling water. What happens? Boiling water, suppose you are taken 10 liter of water and after boiling you are measuring temperature. Suppose it take 15 minutes to boil. Temperature is noted, it is 100 degrees Celsius. After 20 minutes, its temperature will be also 100 degree. After 1 hour, temperature also 100 degrees Celsius. So delta T means T2 minus T1. First temperature 100, second temperature 100. 100 minus 100, answer will be 0. That's why delta T is equal to 0. Okay. Third temperature 100, first temperature 100. 100 minus 100, answer will be 0. So it suggests that delta T is equal to 0. T2 minus T1. Because temperature initially remains same, in middle remains same, at end remains same. That's why delta T is equal to 0. And internal energy is related to the temperature. Temperature changes, internal energy changes. Temperature increases, internal energy increases. Temperature decreases, internal energy decreases. But temperature remain constant, means internal energy remain constant. Delta T is equal to 0. Therefore, delta U is equal to 0. Okay. And to maintain the temperature constant, heat will be absorbed or released. For example, boiling water, you are supplying the heat from the bottom. Temperature rises to 100 degree. Then what happens? To not increase the temperature, the excess of the heat is released in the form of vapors. Okay, that's why Q is not equal to 0. So we'll this detail in learn in detail later on. First of all, first point of characteristics. In this process, the temperature at initial state, final state, and throughout the process remain constant. Delta T is equal to 0. Just I have given you the example of boiling water. Suppose water boil at 100 degrees Celsius. 10 liter water you are taken, after 15 minutes it's boiled. So what is boiling point after 15 minutes? 100 degree. After 20 minutes it also 100 degree. After 30 minutes it also 100 degree. Means at initial state, at final state, and throughout the process temperature remain constant. It is 100 degrees Celsius. That's why delta T means final temperature minus initial. 100 minus 100, answer will be 0. Therefore, delta T is equal to 0. So that is the first point we have explained. Now we are going to focus on the second point. Internal energy of the system remains constant, hence delta U is equal to 0. Just I have given you the explanation that internal energy is temperature dependent. If internal energy is going to temperature is going to change, then internal energy is also change. But is there change in temperature? No. Delta T is equal to 0. Definitely delta U is equal to 0. If internal energy is related with temperature, if temperature changes, if temperature increases, internal energy increases. Temperature decreases, internal energy decreases. But in this case, isothermal delta T is equal to 0 means delta U is also equal to 0. So that is the second point. Now, point number 3. In this system, the process exchange heat energy with its surrounding to maintain the constant temperature, hence Q is equal to 0. Just I have given that whenever the temperature is going to change, this temperature remain constant. To maintain that temperature constant, energy is exchange, it is released into the surrounding. That's why Q is not equal to 0. Means in this process, the exchange of heat energy with surrounding to maintain temperature constant, hence Q is not equal to. If heat is absorbed, then Q will be something positive. If heat is released, Q will be negative. And heat energy is absorbed or released, both is happening. That's why Q is not equal to 0. Now, in isothermal process is carried out in a closed system. That system is closed. And point number 5, in case of exothermic process, liberated heat is given to the surrounding, and in case of endothermic process, heat is absorbed from the surrounding. So that temperature of the system remain constant, delta T is equal to 0. It is very important. Suppose we are considering boiling water. Its temperature is 100 degrees Celsius. What happens? Water absorbs the heat from the bottom and temperature rises. But when it reaches to the 100 degrees Celsius, it further not rises. From that, excess of heat is given in the form of vapors to maintain the temperature constant, that is 100 degree Celsius. Therefore, here in exothermic means heat is given out. Exo means bahar, heat is given out. And in endothermic process, heat is absorbed. For example, ice, its temperature is 0 degree Celsius. To maintain the temperature 0 degree Celsius, it is absorbing the heat from the atmosphere and it's going to melt. That's why the excess heat is given out. So this is the criteria when you are considered. Okay. So our thermodynamic process you are considering, it's isothermal process. Its temperature remain constant. Clear? थर्मोडायनामिक प्रोसेस में पहली प्रोसेस है आइसोथर्मल प्रोसेस. ऐसी प्रोसेस जिसका टेम्परेचर सिस्टम में थ्रू आउट कैसा रहता है, कांस्टेंट रहता है, उसे हम कहते हैं आइसोथर्मल प्रोसेस. हियर डेल्टा टी इज इक्वल टू 0. एज डेल्टा टी इज इक्वल टू 0, डेल्टा यू इज इक्वल टू 0 एंड क्यू इज नॉट इक्वल टू 0. इन आइसोथर्मल प्रोसेस हमको ध्यान में रखना है कि टेम्परेचर ही चेंज नहीं हो रहा है, मीन्स डेल्टा टी इज इक्वल टू 0. एंड इंटरनल एनर्जी ऐसी है, वो टेम्परेचर पे डिपेंड करती है. टेम्परेचर बढ़ा तो इंटरनल एनर्जी बढ़ेंगी, टेम्परेचर कम हुआ तो इंटरनल एनर्जी कम रहेंगी. अगर टेम्परेचर कांस्टेंट है तो इंटरनल एनर्जी फिर भी क्या रहेंगी, कांस्टेंट. डेल्टा टी इज इक्वल टू 0, देयरफॉर डेल्टा यू इज इक्वल टू 0. बट क्यू इज नॉट इक्वल टू 0 because to maintain the temperature constant, heat is absorbed or heat is released. If no absorption of heat, no release of heat, then Q will be 0. But here heat is given out, that's why Q is equal to 0. पहला पॉइंट क्या बोलता है? In this process, the temperature of initial state, final state throughout the process remain constant. Means इस सिस्टम में इनिशियली, मिडल पोर्शन में और एंडिंग पोर्शन में सभी जगह टेम्परेचर कैसा रहेगा, कांस्टेंट, बिकॉज डेल्टा टी इज इक्वल टू 0.